Is there one of these that you'd like to look at? Yes, sir.
Like 3, 4, and 5.
3, 4, and 5. Good start. So for those watching the video, I apologize, I started late again. Just basically went through a few announcements and talked about the quizzes that are due, the one due tonight and then the one due next Tuesday. And now we're going to look at some of the homework. So cosine of pi over 2. So when I see any of these as pi over 2 or it's pi or it's 0 or 2 pi, I usually do triangles, but in that case, I usually start thinking unit circles. So I'm going to come in here. What color should we use today? Hey.
Green.
Green it is. Good choice. All right. Number 3 here from this homework set. And we want to know the cosine of pi halves. And the reason I think unit circle in these is it's relatively easy to think of unit circle. Ooh, that was not a great line, but we'll pretend. If this is 1, then it's kind of this circle, right? Oops, I drew that not great. So on the unit circle, at least, the pi over pi halves ends right here. So our angle is really this angle that we're talking about. Okay, and the coordinates of that point on the unit circle, right? If this is 1 unit away, this is -1, this is +1, this is -1. Then the coordinates of that point are just 0, 1. So the cosine of that point is the x value at that point, which is 0. Does that make sense? Okay. So let's look at the next one. It says the tangent of 3 pi over 2. So kind of similar. Get back to green here. We said that was 0. Three pi over 2, and again, if this is pi over 2, this is pi, right? So that's pi halves, so this would be 3 pi over 2, and then 4 pi over 2, 5, 6, 7, 7. So this is our point in the second one here, and it says the tangent. Well, the coordinates of this point are 0, -1, right? X, y. So the tangent, which we're saying is y over x, or sine over cosine. So that means we're going to take our y value, which is -1, and say over 0. Well, -1, you can't divide by 0, so this one is actually undefined. So you come in here and say, expression is undefined. There we go. Number 5, very similar, cotangent. Cotangent's a little bit different. Cotangent is defined as basically that flipped, so it's x over y. So in this case, we're actually going to have 0 over -1, and that's okay. You can divide -1. It goes in 0 times. So we can find the cotangent, and it is 0. Okay. Other questions from this section? None. Well, just pick a number then.
Can we do number 10?
Number 10. Very good. You don't have to have a specific one that you want to look at. You can just pick a number. It's fine with me if we haven't done it already. Find the exact value of each of the remaining trig functions of theta. And it's given us cosine theta equals 15 over 17. So this is number 10. So let's come in here. Make sure we're green. So number 10. It's given us some information. Cosine theta equals 15 over 17. And it's given some angle information. Theta is between 270 and 360 degrees. So that tells us what quadrant it's in, so that's helpful, really. It's in that fourth quadrant, right? Because that's your 270. And here's kind of your 360 or 0. So it's somewhere in that quadrant. The adjacent side length of this triangle, if you think in terms of triangle, is going to be 15. And the hypotenuse, so I've got some angle out here, which this adjacent side is 15, and the hypotenuse we're saying is 17. Okay, so we need to figure out what this value is. Now this is kind of easy to look at from a triangle perspective. First off, notice it's going to be negative, right? Because if this point is on a circle, the coordinates of that point are, 15 comma whatever the y value is, it's going to be negative. Also, because it is in this quadrant, right, you had A, S, T, C. So it kind of makes sense that cosine is positive. So sine should be negative, tangent should be negative, cosecant should be negative, cotangent should be negative. Secant should be positive because it's the flip of cosine. So we know some stuff. The way I would recommend doing this is just by using the Pythagorean theorem here, because you have a right triangle and you have a hypotenuse and you have one of the sides. So I would set this up. Let's call, what do you want to call this, A or B?
B.
B. All right. So I'm going to have A squared, adjacent side really, so that makes sense. 15 squared plus B squared equals my 17 squared. So 15 squared is what, 225 maybe? Somebody tell me. Anybody got a calculator? What's 15 squared?
225.
All right, and 17 squared, 343? Nope.
289.
289. Oh, okay. Okay, so 225 plus b squared equals 289. So we'll subtract 225 from both sides. And that's going to give us b squared equals, let's see, 9 minus 5 is 4. 8 minus 2 is 6. So b squared equals 64. Well, that's good. I'm going to get b equals then plus or minus 8. If you take the square root of both sides, that's what we get. So the way I like to label this is I like to come in here and say, well, I'm going to make that negative 8. So the coordinates of this point on this circle, really, I guess you could think of too, or the point, it would be the point 15 comma negative 8. Now keep in mind, it's not on the unit circle, so I can't just use x and y. You have to use r times x or r times. Okay, so as I come in here though, and I look at this, I come in and I say, all right, the sine of theta then is going to be the opposite side over the hypotenuse. So it's going to be negative 8 over 17. The cosine is given to me, but it is 15 over 17. Tangent of theta is going to be the opposite over the adjacent side, so that's going to be negative 8 over 15. So then the cosecant of theta is sine flipped, so it's going to be negative 17 over 8. The secant of theta is cosine flipped, so cosine was given to us, so it's going to be 17 over 15, and it is positive. And the cotangent of theta is the tangent flipped, so it would be negative 15 over 8. All right, so let's plug those in. Negative 8 over 15. No! Oh my goodness, we've already messed something up. Negative 8 over 17. I just entered it wrong. Okay. Tangent, we said, was negative 8 over 15. Secant, 17 over 15. Cosecant, we said, was negative 17 over 8. All right, and cotangent, negative 15 over 8. Okay, questions on that and how we got any of those answers? Everybody okay with that? It's a good question.
Could you go back over how you set the triangle in the very beginning?
Yeah, so we know cosine's positive, so that's one thing. So the fact that cosine is positive tells us that we're either going to be in this quadrant or this quadrant. We have to be because cosine is positive. Secondly, it does tell us where theta lies. So it has to be between 270, which is right here, and 360 degrees, which is over here, right? So it has to be in that, so it can't be here, can't be here, can't be here. So I just kind of draw out a little scaled out version here, and I say, all right, it's somewhere, and it's obviously is not to scale probably, but I know that this side of my triangle has to be 15, and I know the hypotenuse has to be 17, based on what is given.
How do you determine the 15?
Because it is the adjacent side of my angle, right, or triangle.
Because cosine is adjacent.
Because adjacent, yeah, because cosine is adjacent over hypotenuse. So if this had been sine equals 15 over 17, then I would have come in and I would have drawn my triangle like this. You know, it's the same triangle basically. But I would have come in and said, all right, this is 15 and this is 17. Because it would be my opposite side over my hypotenuse. Okay. Other questions? All right. So I'm probably going to move on. This one is very similar to the last one. Let's think about where this one's at, though. At least discuss that. Right? Tangent of theta is negative. So that means it is not in quadrant 1 because everything's positive there. It could be in quadrant 2. It cannot be in quadrant 3. So it's either going to be in this quadrant or this quadrant, right? The S or the C quadrant. Otherwise, it'd be positive. Secondly, it says secant is negative. Secant is the reciprocal of cosine. So that means cosine is also negative. So cosine in this quadrant is positive, so it can't be in that quadrant. So it has to be in that quadrant right there. So if I were to come in here and try to draw that one for number 11, I would come in and say, all right, it has to be in that second quadrant for both of those conditions to be true. Secondly, I would look at tangent. Tangent is opposite over adjacent. So if I draw any triangle in here, it's going to have the same kind of look. It's just a matter of what do I make the sides. Tangent is negative 1 over 4. So opposite side, I'm going to make 1. My adjacent side, I'm going to make 4. Now, I'm going to think through this and say, all right, which one's negative? Well, in this case, this 4, this x coordinate is what's going to be negative. My y coordinate is still positive at a point up here. And the hypotenuse is always positive. So you'd set this one up exactly the same, except you would have c squared equals 1 squared plus negative 4 squared. So you would go through that process, figure out what c is, and then you can find everything from there. It's probably going to be a root in this case, so it's a little tricky. Because you got c squared equals 1 plus 16. C equals really plus or minus square root of 17, and it's our hypotenuse, so I'm going to say it's square root of 17 positive. Okay, so you could go through the same process here. Just to point out, sine would be 1 over square root of 17. Which is not going to work because I have a radical in my denominator, so I need to multiply top and bottom square root of 17. So if you do that, you get square root of 17 over 17. Okay, so, but that's enough of that. Let's move on. Those are good questions. We can come back and spend some more time on homework as needed. 4.5 is an interesting section. One of the things I like to do at the very beginning is come in and say, what are the kind of measures? And these are kind of things, these are different ways of calculating your sine, cosine, tangent of all these kind of common angles, right? So I like to just come in, make sure we're all on the same page for these common angles, and then because of that, we can find reference angles and figure out the sine, cosine, tangent of anything that has that as a reference angle. So first off, when I say theta equals 30 degrees, what is that in radians? That is actually pi over 6. All right, and you can do that. That would be 30 times pi over 180. 30 goes into 30 one time and goes into 180 6 times, so it is pi over 6. For a 45-degree angle, what's that radian measure? Pi over 4. And you can go through the math and do that, but just kind of knowing these three at least is helpful. And then theta equals pi over 3, so what's that in degrees?
60.
It is a 60-degree angle. So those are our really 30, 60, 90, and 45, 45, 90. Those are kind of our common triangles that hopefully we know, or getting to where we know. And again, this is the same thing. You're saying pi over 3. In this case, you're saying times 180 over pi. So the pi terms cancel. 3 goes into 180, etc. So the way I do these, again, is maybe a little different than the way you do it. I come in here to each of these. So for this one, 30 degrees, this is the same thing here, right? That's 30 degrees. Either case, the small side I represent as 1. The hypotenuse I represent as 2. So that makes the other side square root of 3. And I just kind of have these memorized. It's up to you whether you do it this way or use unit circle and other things. For theta equals 45 degrees, the small side is again 1. It's always 1. But the hypotenuse in this case is not just 2. It is the square root of 2. Okay? And I come in, I can label these triangles, and then that allows me to find trig functions for those angles. So when I see sine of 30 degrees, sine of pi over 6, I think, well, that's got to be 1/2. Cosine would be square root of 3 over 2. You know what? This is, I'm afraid I can't see that. I'm going to mess something up, so I'm going to go ahead and reset. Okay. Tangent, 1 over square root of 3. Rationalize your denominator, you get square root of 3 over 3. Cosecant is the sign flipped, so it's just 2. Okay? Questions on that? And this is just a review, really. It's kind of setting us up for the next part. But sine of theta is 1 over square root of 2. And we've done this a couple times. Rationalize your denominator. It's not the greatest 2 in the world, but oh well. Square root of 2 over 2. Same for the cosine. The tangent is just 1 over 1, or 1. Secant is cosine flipped, so which is actually square root of 2 over 1 instead of 1 over square root of 2. And you could do the others. This one you have sine of theta, sine of pi over 3. You go to opposite side square root of 3 divided by 2. Cosine is 1 over 2. And tangent is square root of 3 over 1. So just square root of 3. Cotangent would be 1 over square root of 3 then. Multiply both top and bottom by square root of 3. You get square root of 3 over 3. So is there any question on kind of setting those up and at least being able to find those values? Okay. So I'm going to move on. So this is just kind of review. We're going to kind of use that information. But we're going to look at the graphs of sine and cosine functions. And this is kind of tricky. Now, it's going to be harder probably to do this in class on paper than it is online. You get online and you got the little tools. And, hey, this is a sine function. You enter a few values and it's basically graphing it for you. I am going to give some quizzes, a quiz or two on graphs of sine and cosine, in which you will need to do it by hand and not just on the computer. And it'll be fairly basic, but I do want you to be able to kind of understand where those values are coming from. So one way you can kind of do this is just like if you were in algebra and you wanted to graph a function and you didn't know the behavior of that function, is really just look at a variety of points and then connect those points and kind of figure out where you are. So as I come in here and I look at, you know what, probably a good idea. And I've got it here. 4.4. I'll just go to the bottom instead of rather redrawing everything. So as I look at a 0-degree angle, what is the sine of this 0-degree angle?
0.
It is 0. It's the y-coordinate on the unit circle, so it is 0. So I'll flip back over here. I'll say, all right, sine of 0 is 0. Pi over 6, again, that's 30 degrees. Let's take a look at it. What is the sine of pi over 6? So that's this point right here on the unit circle. So what's the sine of that point? Say what? Is 1/2. And again, we've kind of drawn that out above as well, right? If you go back up here, well, the sine of that is 1/2 for 30 degrees. So we got 1/2. And then pi over 4, we already know the sine of that. We've talked about that a little bit. So I'm going to kind of write in here maybe a little bit too. That's 0.5. So when we start graphing these, I might want a decimal answer as I start graphing points here. Pi over 4, again, that's a 45-degree angle. And the sine of that we said was square root of 2 over 2. So let's figure out what that is decimally while we're at it, maybe. Let's see, what is square root of 2 divided by 2? And let me get rid of that symbol. All right, we have 0.707. So 0.71, why not? Pi over 3, that's a 60-degree angle. And we can come in here and we know that that's a square root of 3 over 2. But in terms of decimals, let's calculate that as well. Square root of 3 over 2. Let's just go back in here and I'll just say that. And it is 0.866, 0.87. Okay, so we're just basically doing the same thing you're doing out. I'm picking some points and I'm plotting an x and a y value for sine x in this case. Sine of pi over 2, if you remember, that's your 0,1 point, so it is a value of 1. So if we come into a graph and say, all right, let's just plot some points to start with. I've got 0, 0. I've got, what do we say, pi over 6, comma, and then the decimal value we said was about 1/2. Okay, so we've got a couple points, and then we've got pi over 4 and 0.71. Okay, another point, and then we got pi halves and 1. So okay, so we can look between 0 and pi halves, and we're already getting a pretty good idea what our graph's kind of looking like here, right? So it's kind of coming up here. It looks like it's a curve. It's not just a straight line. So let's find some more points, right? If I plug in 2 pi over 3, so this would be really 120 degrees. So in that case, our reference angle at 2 pi over 3, that's the angle between this angle and the x-axis is the same as the 60 degrees, right? So you'd take 180 minus 120. So it's going to be the same as this over here, really, square root of 3 over 2. And you could kind of sketch that out if you wanted to. That's kind of this angle here. And we're saying our short side again is 1. I'm sorry. Yep. Square root of 3. That's negative 1. And then 2. So our sine would be square root of 3 over 2. Which we said was at about 0.87. And the sine's positive up in this quadrant, so we're okay. And we can keep going with that, right? Square root of 2 over 2 for a reference angle of pi over 4. So it would be 0.71. Again, that would be 135 degrees. 5 pi over 6 ends up being 1/2 again, right? So it would be that situation where you're drawing your triangle out here. And that's your 1. This is your negative square root of 3 and 2. So this is your 5 pi over 6 case. So 0.5, this we said was 150 degrees, or 5 pi over 6. And then the sine of pi we said was 0. All right, so far we're just plugging points. You could plug these in your calculator. Not that big of a deal, but let's keep drawing on here. We're going to say 2 pi over 3, comma 0.87. 7, I believe, again. Is that what? We didn't do pi over 3, did we? Or did I just skip it? Yeah, there we go. And let's see, we did 3 pi over 4, square root of 2 over 2. Okay, so you can plug those in directly in Desmos too. You don't have to give decimal answers, but and then we've done a couple more. 5 pi over 6, comma 1/2. And finally, pi, comma 0. Okay, so you can look at our points here and kind of see we've got a nice little graph between 0 and pi. We've got a nice little loop here. You could even draw that out if you wanted to. In fact, let's just do that. Sine of x. But I want to limit it for now at least, where x is between 0 So that's kind of what our graph looks like, between 0 and pi. So if we keep going with that, and you can, if I look at 7 pi over 6, and I come in here as well, 7 pi over 6, that is, again, a pi over 6 reference angle. So it kind of gives me this triangle. So I have -1, negative square root of 3, and 2. So in this case, it's -1/2, negative 0.5. And that would be at 180 plus 30, or 210 degrees. And you could keep going. I've got a few others in here. I've got 4 pi over 3. That's 3 pi over 3. So 4 pi over 3 is that 180 plus 60, or 240 degrees. And that would be negative square root of 3 over 2. And then finally, 3 pi over 6. I think I meant for that to be a 2. 3 pi over 2. The sine of that is -1. That's this point down here. So we could keep going. 7 pi over 6, -1/2. Okay, and we did 4 pi divided by 3. Comma 3, 2, that was negative, and -1. So 3 pi divided by 2, comma 4. Okay, so we got some more points that we've kind of plotted out here, and you can kind of see it's kind of following that same trend, but down here below the axis. So if I let this go on between 0 and 2 pi, you can kind of see that this is what the graph of one period of a sine function looks like. Just based on points and just kind of plotting the curve through that. We're going to find kind of shortcuts for kind of evaluating this and figuring out how to graph this. But that's kind of where we're at. So if we keep going, we could, right? We could take 2 pi and add pi over 6 to it. Guess what? We're going to be at the exact same point we were earlier, because all I've done is taken that point and added 2 pi to it. It's going to be at the exact same y value. Remember, sine and cosine have a period of 2 pi. So this graph is essentially repeated to the left and right. And if you look at that, if I say, well, let's make that go to 3 pi, right? It's just going to repeat 4 pi. 20 pi, right? It's just a repeating function, and these are really called periodic functions because they repeat after a period, right? And they're used to model a lot of things. So that being said, we know kind of some characteristics, hopefully, of a basic sine function between 0, and I'm just going to focus right now between 0 and 2 pi. So here's our kind of basic sine function. Cosine is very similar, but right, it's just different values. I think what I will do well, let's just go in. Cosine of 0, we're going to say is 1, right? That's that 1 comma 0 point. The cosine of pi over 6, if you calculate it, is square root of 3 over 2. The cosine of pi over 4 is square root of 2 over 2. And the cosine of pi over 3, that is your 1/2. Cosine of pi halves is 0. And you can calculate this. I'm not going to go through the process of doing this over and over and over. The cosine of 2 pi over 3, it is negative 1/2. Remember, cosine in that second quadrant is negative. So this graph's going to look a little bit different. It's really just kind of shifted. So let's go in, why not, and let's plot some of these points. First thing I'm going to do, though, is make some of these invisible so we don't have to get confused between sine and cosine, at least to start with. I'll leave that for now. All right, so there's our points. We can even get rid of that. And I missed one somewhere. That's okay. So for cosine, we started at 1 comma 0. I'm sorry, 0 comma 1, right? Here our x value is 0, our y value is 1. Okay? So our graph of our cosine at 0 is going to start at 1. And then we're going to come in here and we said, all right, pi over 6, comma, square root of 3, I'll keep doing that, divided by 2. There we go. And pi over 4, comma, 1/2, square root of 2 over 2. Pi divided by 3. And then finally, when we get to pi halves, the cosine is now 0 because it's our x value. Okay, so you can kind of see that, and you can keep going with points on that. In general, though, you get this. We'll do the same thing. We'll say between 0 and 2 pi. Okay, so it looks a little bit different. It is repeated. If I let that go on out here to, say, 8 pi or whatever, it does repeat just like the sine curve did. It's just really starting at a different point at 0 as opposed to what we were before. Okay, so this is basic sine, basic cosine graphs. Now what we do with those is we're going to set those up a little bit differently. We're going to do things. In particular, we're going to change how high it goes and how the amplitude of this curve. We're going to change the period, how much it's squeezed in, how much it takes to repeat, and things like that. And then we're going to shift it left, shift it right, shift it up, shift it down. And different things have that effect. So as we look at, well, maybe. Okay. Okay, so we've kind of graphed these online. I'm not going to draw these by hand right now. We will at some point. Okay, so what we've looked at so far was sine of x. I want to use the board so bad. I'm so used to it, but I'll try to use the screen since I'm recording and stuff. So now, if we change that a little bit, this a, if we put a constant out front, then this a times sine of bx, or b times, or a times cosine of bx, that a is what really controls how high or low our graph is going to. It controls the amplitude. So that constant out front of sine is going to control that. So that kind of makes sense. If I go back up to my values, if I made this, say, 2 sine of x, then I'm just basically saying, well, this is still 0. This would be 0.5 times 2, which is 1. So I'm just basically doubling each of these, right? You're just making it twice as tall and twice as much in the negative. So that's the effect of really adding anything to that. Let's just graph them both up here. Actually, I'll come back to cosine in a minute. You can see if I just put a 2 out front, it just goes that much taller, right? If I put 3, it goes that much taller. So that's all you're really doing that. Now negative, if I put a negative sign, that's a little bit different. So if I make that negative 2, instead of starting all my values going up double, they're going on not just double, but they're flipping around the axis. So that negative sign x is really just flipping it around that x-axis. So instead of being at 1, I'm at negative 1. Instead of being at 1/2, I'm at negative 1/2. Right? So that's what a negative sign does out front, and that's what the amplitude controls out front. Let me get rid of these points for now. Okay. So that's what the A value does. This thing locks up sometimes when I go back to that screen. So go back to here and here. There we go. Man, that didn't work. Okay, so that's what this A does. Now this B sign in here, A sign of BX, so a constant or some kind of multiplier on the inside, that changes the period of my function. Okay, so my general sine function, right, sine of x, we kind of said it was going to be between 0 and 2 pi, right? And that was for sine of x. So if I change that x, if I make that b of x, so instead of letting x go between 0 and 2 pi, I want b of x to be, between 0 and 2 pi. What's going to happen is if I divide everything through by b, divide this through by b, divide this through by b, divide this through by b, this one goes to 0 still, less than or equal to x, less than or equal to 2 pi over b. So that's what our period is really represented as, is 2 pi over b. So this amplitude, the absolute value of that A value, is going to give me how high or low it's going to go. If I take 2 pi divided by the multiplier out front, this bx, that's going to tell me how long between 0 and what is my graph going to complete one period. So if I do that, let's just say I make this, 2x, for example. So you can see between 0 and now pi, that is one period. So 2 pi over 2 is pi, so that should be one period. Okay. If I make that 4, guess what? 2 pi over 4 means that it's going to repeat every pi half. So there's one period of our function is done at pi half. So that's changing really how much it's squeezed in or out in the x direction. Okay? Now, and we'll get to shifting in a little bit, but the max min y value of sine x is, really 1. That's the amplitude of a sine or cosine function, and the period is 2 pi. Now, if I have the different numbers in here, like for example, find the amplitude of negative 3 sine of 2x. Well, the amplitude is going to be the absolute value of that, so it's the absolute value of negative 3. So it's going to be positive 3. Now the negative sign, remember, it flips it to the negative instead of going positive. So it's going to flip it, but it's still going to go 3. The amplitude is still 3. It just starts negative instead of positive. The period, in that case at least, is 2 pi divided by whatever that multiplier is here. So it'll be 2 pi over 2, or pi. Okay. For my other function here, I'd say, well, my amplitude is absolute value of 4, which is 4. The period, I would say, well, it's going to be 2 pi divided by 1/2. Well, I've got a fraction in the denominator, so that means it's going to be 2 pi times the reciprocal of 1/2, which is 2 over 1. So now my period is 4 pi. Okay. So just being able to find amplitude and period, that's going to be helpful, as we'll find out. Now there's really, if you go back to our graph, there's really some key points in this graph. First is this initial point right here, this 0, 0. Let's just see, we've got that one here. We'll point it out. we also had pi halves 1, right? So we're at 0, 0. We're going to kind of curve up here, and we're going to flatten out at around pi halves, or at 90 degrees. We're going to flatten up here at whatever our amplitude is. In this case, it's 1. And then we're going to come back down, and we're going to get back to the x-axis at pi. Let's say we got that one plotted too, so we'll go ahead and point it out. And then really we're kind of back down here at negative our amplitude at 3 pi over 2. Let's see if we've got that. We do have that pointed out. And then finally we're back here at our starting point at 2 pi. So let's go ahead, let's write that one in here too. Okay. So here's our sine function. Kind of looks like this. And we got these 5 key points. Now, if we're going to, the way I'm going to look at these, when you're graphing these by hand, that's what I'm going to look for. I'm going to look for 5 key points of a sine graph. And it's going to have that shape, and it's going to have those endpoints, it's going to have the correct amplitude, and it's going to be plotted out that way. Now, there's different ways to do this. One is you take your first point and your last point. So as I want to find the x values for these 5 points, if I say, all right, between 0 and 2 pi, I can come in here and say, all right, I've got 0, and I've got 2 pi. If I split that in half, right, I'd be at pi. If I split that in half, I'd be at pi over 2. So I would have these key points: 0, pi halves, pi, 3 pi halves, 2 pi. So if my period changes, I'm going to do the same thing. So if my period was pi, I would have 0 and pi halves, pi fourths. So you're just going to split it in that way. Another way is you can say, all right, if 0 is my first point, my whole period is whatever, in this case 2 pi. If I take that 2 pi and I divide that into intervals, basically saying I want to split that, divide it by 4, then what that tells me is I'm going to take my period, divide it by 4, and I'm going to add it to my first point. And then my second point is going to be my first point plus that pi over 4. My second one's going to be the period divided by 4 plus my previous point. And I keep going until I get to that last point. So, might not make much sense, but let's try to do one of these, and we'll kind of, hopefully it'll make more sense. And let's see, draw. Okay. Okay, so first thing I would recommend is if I give you a function, here's an example, you might see this on a quiz or something, y equals 2 cosine of 1/2 x. You might want to first note the amplitude I'm asking you to here. What is the amplitude of this function? It is 2, right? It's absolute value of 2, so it is 2. What is the period of this function? It's 2 pi over what? Over 1/2, right? So that means it's 2 pi times 2 over 1. So it is 4 pi. Okay, now I haven't shifted anything left, right, or up or down yet. So that means for a general cosine graph, I can start plotting this out a little bit between 0 and 2 pi at least. So, all right, my first point is going to come somewhere here at 0, and then out here somewhere I'm going to have this 4 pi is my period. Okay, so there's different ways to come up with these key points, right? You could take that in half and say, all right, that's 2 pi. And if I split that in half, I'm at pi. So that's one, and we talked about that. The other way is I could take this whole period, right? 4 pi, and I could say, well, if I split that, if I say my period divided by 4 in this case would be 4 pi over 4, or just pi. So that means if I start at 0, and this one hasn't shifted, so I start at 0, I'd be at 0 pi. Pi plus pi is 2 pi. 2 pi plus pi is 3 pi. And 3 pi plus pi is 4 pi, which is be my last point. So I have 1, 2, 3, 4, 5. 5 key x points. And then other than that, this is the same as the graph of a cosine graph. All I've done is change the amplitude. So instead of being at 1, I am at 2. So a cosine graph, if you remember, started at 1. So we're not going to start at 1. We're going to start at 2. And then at our next point, we crossed our x-axis. At our next point, we were at negative our amplitude. So we'd come down here and say, all right, if that's kind of 1, negative 2, I'd be right here. and then I'm back at my x-axis, and then I'm back at my amplitude. So you could come in and say, all right, this isn't great, but it's a rough sketch of what a cosine function between 0 and 4 pi would look like, and then it's going to repeat to get to 8 pi. Okay, so it's really a matter of kind of just memorizing where those points are on a sine and on a cosine graph. For a sine graph, you start at 0, you go to amplitude, you come back to 0, you go negative amplitude, and then back to 0. So it kind of looks like this. Cosine graph, we said, was a little bit different. We started at amplitude, positive. We went down to 0. We went down to negative our amplitude, back to 0, and then back up to amplitude. So cosine is kind of starting at amplitude, or whatever your AE value is. And the sine is starting at 0, which makes sense. Sine of 0 is 0. Cosine of 0 is 1, or amplitude. Okay. So we could do that again. Y equals 3 cosine x. Guess what? It's just a little bit different. If we wanted to draw it, we could do the same thing. We could come in and say, all right, 3 cosine x between 0 and 2 pi. In this case, our period is 2 pi. So I'm going to come out here and say, all right, there's my 2 pi. Actually, I need to make that down here, I guess. My amplitude is 3. So I'll just come up here and say, all right, let's make that 3, and I'll make this negative 3. 2 pi divided by 2, that's just my pi. Divide that in half, I get pi halves. So pi halves, 2 pi halves, 3 pi halves. So it is a cosine function. So I start here. I go to 0, I go to pi, back to 0, and then back to amplitude. Okay. Okay, so we can do that, I think, fairly well. Phase shift is where it gets a little tricky, because now we're not necessarily starting at 0. We're going to kind of plug in the shift value. And this one's a little harder. I don't ask you to do too many of these as far as on paper graphing. I will let you use, Desmos and things like that for graphing these. But really, all you're doing is you're saying, all right, I'm going to take my whole graph, and I'm either going to shift it left by an amount or I'm going to shift it right by an amount. Other than that, your graph is not changing, and it's even very similar to the way it is written. So when I see something like this, y equals a times sine of bx minus c, your amplitude is still a, the absolute value of a. Your period is still 2 pi over b, that multiplier of x. Your phase shift, now again, is going to be c over b. Notice that it is defined as bx minus c. So you're going to almost do the opposite of what it says in there. So if I see something like this one where I see 3 sine of 2x minus pi over 3, there's things you can do. First off, I'll ask you, what is the amplitude of that function? It is 3. All right. What is the period of that function? It is 2 pi over 2, which is pi. That is correct. So for phase shift, it's a little bit different, right? It's c over b. So in this case, our c is positive, right? Minus, this is positive, so it would be pi over 3 divided by b, which we said was 2. Okay? So we're actually shifting this one to the right, because again, this is defined as bx minus c. So that is pi over 3 times 1 over 2, or pi over 6. Okay? So that all looks good. Now when you start graphing this, this is where it gets a little more interesting. So you can either just basically take your graph without shifting it and then just shift it at the end, or you can come in from the beginning and figure out what your x values are and then draw your graph as you normally would. So I'm going to go by that approach, I think. So I'm going to start with a phase shift of pi over 6. So instead of being at 0, I'm going to start, my point 1, in x at least, is going to be at pi over 6. My point 2 is going to be a little bit different, right? So if I start at pi over 6, I want to add to that my whole period divided by 4. I want to take that whole chunk, I want to divide it into fourths so I can get those points. So my period divided by 4, in this case, would be pi over 4. So if I take pi over 6 and I add that pi over 4 to it, that's going to give me my second point in x. Well, let's see what that is. Let's find a common denominator. That would be 12. So if I multiply this, I'm going to have 2 pi over 12 plus 3 pi over 12. So I get 5 pi over 12. So that's my next point. So to get my next point, I would add another pi over 4 to that. Right? Because that's my period divided by 4. So I would take 5 pi over 12, and I would add pi over 4, which we just determined was 3 pi over 12. And I would get 8 pi over 12. Okay, well, that's the same. If you divide 4, it goes into both of those. 2 pi over 3. So my point 3, I'm going to say is 2 pi over 3. And then I'm going to keep going down that road. I'm going to say, all right, so if I take 2 pi over 3, it's 8 pi over 12. And I add that again, 8 pi over 12 plus 3 pi over 12. I get 11 pi over 12. Okay? And finally, my point 5 that I'm looking for, I'm going to take 11 pi over 12, add that 3 pi over 12, or pi over 4, and I get 14 pi over 12, which is 7 pi over 6. Whew, that's a lot of writing. So here are kind of your key points. Now, first thing you might notice is your period. We said our period was pi. So that means as we go from point 1 to point 5, we should have a distance of pi. So if you take 7 pi over 6 minus pi over 6, you get 6 pi over, so it is pi, so that's okay. So you could come in now and kind of graph this. It's not going to be beautiful, but we'll try it. Okay, so I have shifted everything over by pi over 6. And it looks like the smallest denominator, at least I have, is over 12. So I'm going to come in here and I'm going to say, all right, that's pi over 12. I'm going to say these are pi over 12 apart, really. So this would be pi over 6, or 2 pi over 12, 3 pi over 12, 4 pi over 12, 5, 6 pi over 12, which obviously these have different values, I guess. 7, 8 pi over 12. 9, 10 pi over 12. I'm just basically coming in and labeling everything right now. 12 pi over 12, which is pi. And then finally, we keep going with this. So let's see, 11, 12, 13 pi, 14 pi over 12. Okay, so let's kind of figure out what these are in terms of pi over 6, at least, some of these cases, because we have pi over 6, that's our first point, and this is is this a sine or a cosine? It is a sine. So I'm going to come to sine, pi over 6, so that means I'm going to start right there. Sorry, I'm going to start at 0. It's a positive sign, I believe. It is, so I'm going to go up to 3. 1, 2, 3. All right. And I'm going to do that at 5 pi over 12. So there's 4, so this would be 5 pi over 12. I'm going to come up here to 3. And then at 2 pi over 3, I'm going to be back at 0. So 2 pi over 3, let's see, over 12. Let's see, that would be 2 times 4, so 8 pi over 12, I believe. Yep. And then my point 4 is 11 pi over 12, so this is 12 pi, so it would be right here. I'm going to be down at negative 3, so negative 1, 2, 3. And then finally at 7 pi over 6, which would be what? 14 pi over 12. Actually going to be right here. So here's kind of, and this is kind of rough, but it gives you an idea of what your graph's going to look like. And that's just going to repeat. Right? So 1, 2, 3. So 1, 2, 3 down here. So that's kind of a rough sketch. Now this obviously, that's what I'm saying. This is much harder to do by hand. It's doable. And again, the other thing you could have done is just come in here and drawn your basic, let's change colors actually. You could have kind of come in here and said, all right, here's kind of my basic sine function, and then just shifted everything over by looking at the points and saying, all right, I'm going to shift this by this, I'm going to shift, this by this, same amount, and then give you some more points to do it that way. So, phase shift, much harder to do by hand, but still understandable, I hope. Finally, the last thing really as far as the graphing is called a vertical shift, in which case you're just taking your whole graph and you're just shifting it up or down, and that is this D value, and it's not inside the parentheses of sine, but it's on the outside. And that's going to determine how much I'm just taking my graph and shifting it up or down. It's not as hard to account for because I'm not changing anything as far as my period and what my points are in X. It's just changing really the amplitude and where those are. So let's pick a function that doesn't have a phase shift preferably. And let's do a negative. We haven't done much with negative. So somebody tell me, sine or cosine? Sine. All right, so I'm going to have negative. Somebody give me an amplitude. 2. All right, negative 2. You guys sound so excited about this. 2 sine. All right, so I don't know. Give me a value. I don't want a period of just 2 pi. So somebody give me a number that's going to help us account for a period. Preferably an even number. 4. All right, so 2 sine, negative 2 sine, 4 x, and I'll tell you what, let's shift this vertically. Let's say, I don't know, -1. So if I gave you this on a quiz, which I might, something very similar to this, and I say graph, here's what I would recommend doing. I would come in here and say, I think it's helpful to come in and say this. You don't have to do this. I think it's helpful to come in and say, all right, what's my amplitude and period? So what is my amplitude? Absolute value of negative 2 or 2. All right, so that's your amplitude. What's your period? It's 2 pi over 4, or what's 2 pi over 4? Right, can you simplify that? It would be, right, 2 goes into each, the 2 and the 4, right? So 2 goes into 2 one time, and into 4 2 times. So it's the same as pi over 2, right? 2 over 4, the same as 1/2. Vertical shift. Is there any vertical shift in this graph? Yes, right? That -1 outside the parentheses means I'm going to take everything down one place. So I'm going to say down 1. Or you could say shifted down 1 out. There's no phase shift. So that's another way I can ask a question here too, though. So I'm going to give you an equation and say, all right, what are these values? What is the amplitude? What is the period? What's the vertical shift? What's the phase shift? I won't necessarily make you graph a phase shift, but I will have you give me what a phase shift is without graphing. So now that I know that, I come in here and I start drawing some key points out. I say, all right, first off, my vertical shift is down 1. So I go down here and I say, all right, I'm going to let this be -1. My new graph is going to be completely based off this kind of line here. All right, that's my new axis. My amplitude is 2. So if this is 1, if I go up 1, 2, and that is the point 1 here, and I go down 1, 2, That's -2, -3. My graph should lie in there. Okay, so I'm learning some stuff. My period is pi halves. So if I go and say this is my first point, 1, 2, 3, 4, all right, this will be my fifth point. I want this to be pi halves. Okay, all right, this is 0. So that means halfway across would be pi halves divided by 2, which is pi over 4, and half of that would be pi over 8. Okay, so if that's 1 pi over 8, 2 pi over 8, this would be 3 pi over 8. 8, and you could keep going here. That's 2, 3, 4. You could label all these axes that you wanted to. Negative pi over 8, negative pi over 4, etc. But everything should lie between 0 and this pi halves here. Okay. Now it's just a matter of plotting those key points. It's a sine graph, so I'm going to start on my horizontal axis. So I'm going to come in here and say, all right, I'm going to start right here as 0 as far as my amplitude goes. Okay. Now, positive sign, I would come up here, but it's not positive, so that means I'm going to do the opposite of that. I'm going to come down to here. It is sine, so then I go back to my kind of midline, and then I go to positive my amplitude, and then finally I'm back here at my center line, and that's going to give me my graph. And these don't have to be perfect. I do ask that they're curves, not straight lines between these points, because they are not straight lines. So I do ask that you show somehow that that is a curve, not just a straight line. All right. So that would be great as a graph. Okay. Now, could you extend that? Sure. I mean, you're just doing the same things over and over. Oops. I'm not drawing too good there, but that's what I'm looking for. So when I start grading these, I'm going to really just kind of be focusing on this. Now, I will expect you to have your x-axis and your y-axis, at least for that section, labeled. And I'm going to be looking at those 5 key points and make sure that it is, 1, it's a sine graph, so it's starting at 0 or starting at your where you're shifted to, and 2, that it's going the right direction, okay, or cosine. Now, all that being said, if you go to your homework, you're going to find this is much easier, which is good and bad, because it is good. It is much quicker to do. But I don't think you get the practice sometimes that you might want. Somebody pick one between 1 and 18. We may or may not do it, depending on what it is. 12? All right. I just kind of want to point out how these work. All right, determine the amplitude, period, and in graph. So this is what I wanted here. So the amplitude, what is the amplitude of this function, if you can see it? It is 1, okay? The period is 2 pi over whatever's in front of x. So it's just 2 pi over 1, so it is 2 pi. Oops, and I hit a wrong something in there. All right, the phase shift, again, that is your negative, or well, let's see what it is. It is C over B. So in this case, it's 3 pi over 4 over 1. So, but again, this is now plus. So that would be negative 3 pi over 4. So it's going to be opposite this. So it's going to be negative 3 pi over 4 over 1. So it should just be negative 3 pi over 4. So really, it's just, it's that C over B. Just remember, it's going to be opposite what that sign is in there. So if it says plus inside that sign, it's going to be negative. If it says negative inside those parentheses, it's going to be positive. Okay, so now when you go to graph these, you can say, all right, click to enlarge graph, and here we go. This is a cosine function. So you've got options here. You've got sine, cosine. So we'll pick cosine. Okay. And it says click the graph to plot your curve. So I'm just going to click anywhere in there, and it graphs a function. And then all I really have to do is come in here and say, all right, my amplitude is 1, my period is 2 pi, so we said that was 2 pi. We don't have a vertical shift. We do have a horizontal shift. We said that was negative 3 pi divided by 4. Okay, now it's not negative on the outside, so I don't have to reflect it over any axis, all right? So now if I come in here and look at this graph, it's kind of hard to see here. It's not blown up much. But that's kind of what it looks like. Now, I don't have to worry too much about anything else. It's just going to graph everything for me based on the inputs that I give it. So you don't have to worry about P1, P2, P3. So it's much easier to do. That's why I'll let you do phase shifts on it. Okay, I know we're about out of time. Let me take attendance real quick, and we'll be good. Is there a question? Comment? None. Oh, perfect. All right, let's see. Cody is not here. He told me he wouldn't be here. Tawo? All right. Did I say that okay? Okay. Leah Beasley, not here. Peter Bray is here. Kevin Brown, here. Tyler Clark. All right. Leslie is here. Brandon Jackson. Thank you. Amos Johnson. All right. Andrew. Okay. Jerry Mason. Okay. Hannah Miller. Thank you. Jacob Patterson is not here today. Colton Power is here. Sarah Schwartz. Okay. Tim Snyder. Robert Thompson is here. And Zachary Wood. All right, so don't forget your quiz is due tonight. Quiz 1 is due tonight, and then we'll pick back up on Thursday, and we'll keep going. So if you have questions between then, just let me know.
Okay, so the due date on the sheet for the quiz is for the second, because it's saying it's due by Thursday.
I'm sorry?
The quiz sheet they gave out for the second quiz sheet you gave out is saying it's due by Thursday.
It is due a week from today, so it's actually due next Tuesday.
There's something you'll have to fix for next
Say
time.
what?
It's saying that it's due on the 9th of September.
Yeah, the syllabus and those dates are already out the window because where I was out and then we had a weather day, so those are already a little bit shifted.
Here's I know I couldn't submit it. Do you just want the paper one?
Did you send it? You sent it to me though.
I
already
just
looked
texted
at
it. I don't know if that's okay.
Yeah, that's fine.
Is
That's
that
fine.
okay?
I mean, you might want to hold on to it.
Yeah,
But yeah, I got your text, and that's fine. But next time, if you can or you can't figure that out, the reason I do that is I can grade it in Blackboard, and you have your grade, and it's all there, and I don't have to print it or have to pull it over in a different way. So
Okay.
try it
that's
next
fine.
time. Hopefully.